Hey everyone, welcome to another edition of No Hair No Problem. Rosenwald here. You guys were asking for a video on the Unified review, so I'm going to go ahead and try to make one here. I'm going to go kind of quickly through it, but again, if at any point you're wondering how to go back and do it, feel free to watch it again at your own pace, okay? But again, if you can do the review, you're going to be in pretty good shape for the test, okay? So let's go ahead and get started. The first thing we're looking at here is in number one, we're talking about when a problem is in standard vertex form. If you remember, the equation for standard vertex form is y is equal to a times x minus h squared plus k. And so when we're doing this, it's just a matching game. We're taking the stuff that's given to us and we're just matching it up. That when we look at the h, it's right there inside of our formula, and we look at our k, it's right there inside of our formula as well. So let's go ahead and just pull the information from this. For the vertex, remember, we're going to just pull the values out, but recall that with the inside portion, this portion that's on the inside, we always take the opposite. So since I see a positive 6, we're going to go ahead and take the opposite, and it's going to be a negative 6 for the h value. And then for the k, it's just going to be the 12 that's right there. So my vertex for this is at negative 6, positive 12. The axis of symmetry for this is always x equals, and it's going to be x equals the number that's given to us in the problem in the vertex here. These two should always be exactly the same. So that means we're going to have x is equal to negative 6. When we look at the vertex in this, the question is it a maximum or a minimum? And in this case, we have two different options that we can run into. It is a minimum if the a value is positive, okay? And it is a maximum if the a value is negative. And so what we're looking at is the a value that's provided in the problem here is a negative 4. That means that this is a maximum. So it is a maximum, and the maximum y value that's given to us in this problem is from the vertex, which is 12. Okay? How do we know that's a maximum? A is negative. Okay? So let's see what this equation actually looks like if I was to graph this on Desmos. Okay? On Desmos, if we go and graph it, you can see we're going to have y is equal to negative 4, and then we're going to have x plus 6 squared, and then plus 12. And again, we can look at this picture and pull all the information directly from it. That we look at the maximum, it's at negative 6, 12. You can see that it's at the top of the curve, and because it's at the top, we call this a max. If it was at the bottom, it would be a minimum. And then we look at the axis of symmetry. The axis of symmetry we said was x is equal to negative 6. And we can see that we've got this vertical line that goes directly through the middle of my graph, straight up and down here, that creates symmetry where it's the same thing on the right side as it is on the left side. Okay? All right, let's jump over to the second question. So this one, the vertex is not in standard vertex form, so we have to pull information out from here. So in order to do so, we say x is equal to negative b divided by 2 times a. That's going to create our axis of symmetry. That's the value that we're going to use in our vertex to try to find the k value. So if we use negative b over 2a, we're going to use the b and the a value that's given to us. So we're going to have the opposite of 2, which is a negative 2. That's the opposite of this 2 that's right here is a negative 2. And then we're going to go ahead and use 2 times 1, which is just 2. So it's negative 2 over 2. Okay? Which means my axis of symmetry is at negative 1. So we have x is equal to negative 1. The vertex now, to find the k value, we're going to plug in this x value into, so this negative 1 that's right here is going to get plugged in for the x right here and for the x right here. So if we do that, we're going to plug in the negative 1, and we're going to have a negative 1 in place of the x. And if we use our calculator to simplify, we end up getting a negative 16 for my vertex. We know that this problem is going to have a minimum. The reason we know that is because when we look at the a value, a is positive. And because a is positive, it's going to be a minimum value at negative 16. And again, that's how we know that it's positive. Or I'm sorry, we know that it's a minimum because a is positive. Let's go ahead and take a look at this function just so we can look at it and see again what this looks like. We have x squared plus 2x and then minus 15. And we look at our picture, we can see it's at the bottom of the curve now. So because it's down at the bottom of the curve rather than top, this is a minimum. And we look at the axis symmetry, we get x is equal to negative 1. And we can see that that vertical line goes directly through the vertex of my shape. And we can touch the vertex and see it's at negative 1, negative 16. Okay? All right, let's take a look at number 2. This one, what we're doing is we're finding the x and the y intercepts. So to find the x intercept, remember what we do is we set y equal to 0, and to find the to find the y intercept, we set x equal to 0. So we just always do the opposites with the intercepts. So if we're going to find the x-intercept, let's set y equal to 0, and we're just going to use what we learned last unit to solve this. We're going to take the 12 that's given to us, and we have to move the 12 over. So in order to move the 12, we're going to subtract 12 from both sides. And we end up with negative 12 is equal to negative 4x plus 6 squared. Okay, we'll divide both sides by the negative 4, because we want to get rid of this negative 4 that's right here. And so we're going to get a positive 3 is equal to x plus 6 squared. Now to undo the square that's in this problem, remember we take the square root of both sides. So we'll take the square root of both sides, and we get plus or minus root 3 is equal to x plus 6. And so let's finish solving. We move the 6 over to the left, we get negative 6 plus or minus root 3, and that's going to equal x. So if I say what are the x-intercepts for this, we're going to break this into two separate problems. We're going to have negative 6 plus root 3, comma 0, and then we'll have negative 6 minus root 3, comma 0. Those are x-intercepts. Okay? Remember in the directions, it says exact values. It says no decimals are to be allowed here. That's why we got an exact answer here. Okay? All right, let's work on finding the y-intercept. So to find the y-intercept, we're going to go ahead and set, the x equal to 0. So we're going to have f of 0 is equal to negative 4 times 0 plus 6 squared plus 12. Sorry, my stylus is getting a little wonky here. That's a 2. That's a 2 there, square. And if we simplify this, we're going to have f of 0 is equal to, you could throw the negative 4 plus 0, God, that's awful there, 0 times 6 squared. You can throw negative 4 times 0 plus 6 squared plus 12 into the calculator, and you'll see that we get a negative 132. So that means that my y-intercept is at 0, negative 132. Okay? All right, we'll do the same thing with letter B. And again, if you want to try it, I would recommend you guys pause it and try to do the problem on your own, but let's work through this. The x-intercept, we'll set y equal to 0, so we get 0 is equal to x squared plus 2x minus 15. Oh my God, my stylus is going crazy. And then we're going to go ahead and try factoring if we can. Remember, if we can't factor, we go ahead and use the x method or quadratic formula or any of the methods that we learned in our previous unit. I'm going to try factoring here, and it actually does work out very nicely for this one, that when we factor 5 minus 3 does give me that 2, and then 5 times negative 3 does multiply to equal the negative 15. So we know that works out okay. So we're going to solve. We get x is equal to negative 5 and x is equal to positive 3. So that means that we're going to have x is equal to negative 5, 0, and positive 3, 0 for the x-intercepts. My y-intercept, remember we're going to go ahead and set x equal to 0. What does that mean in this kind of function where if I set x equals 0? Well, if I put a 0 right here and I put a 0 right here, what's going to happen is this will be a 0 plus a 0 and then minus 15. So we just end up with a negative 15 for the y-intercept. So it's going to be at 0, negative 15. Okay. Let's go ahead and look at the graphs of these just to confirm all the stuff that we just said. We said that we're finding the x-intercepts here, so we're going to have negative 4 x plus 6 squared and then plus 12. So if I look at my x-intercepts, you can see they're not good, clean values. They're actually a little bit wonky. But if we remember, we said it was negative 6 plus the square root of 3 and negative 6 minus the square root of 3. Okay? And you can check and see that these values do in fact match the x-intercepts that we just found. Okay? If I said let's look at the y-intercept, we'd have to go way down here on my graph to find this, all the way where it hits my y-axis, which is right here, at 0, negative 132. If we look at the second equation that we had there, we had x squared plus 2x, and then minus 15. Okay, let's reset back to the home. And we can look at the x-intercepts and see that's at negative 5 and positive 3, which are the x-intercepts that we said. And the y-intercept we said was all the way down to 0, negative 15, which is right there. Okay? All right, let's go ahead and continue on with solving these. This one, it says, let's go ahead and find the equation given the vertex and the point. So if you think about what's given to us here, we're being given the vertex, which is the h and the k. So we're being given these pieces of information right here. And then we're being given a point, which is this stuff right here, which counts for the x and the y. So the only things that are not known within this problem is the a value, and that's what we're going to work through to try to solve, okay? So if we go ahead and set this up, we're going to have our y value, which is 4. We're going to have the y value, which is 4, is going to be equal to our a value, which we don't know, the x value, which is -1, minus the y value, the h value, which is 2. And then we're going to have, and again, just a real quick reminder, see a +2? We wrote like a -2. It's always the opposite. And then we're going to go ahead and square it. And then we're going to go ahead and say -6, because that's my y value. Or, I'm sorry, my k value. So all we have to do is solve for a. We're going to add 6 to both sides. We end up with 10 is equal to a. -1 minus 2 is -3 squared. So we have 10 equals a times 9. Divide by 9, we get 10 over 9 is equal to my a. So the equation then is the equation that we had with the hk and the a. We leave the x and the y out of it. So we're going to have y is equal to my a, 10 over 9. Then we're going to have x. My h is going to be -2 squared, and then -6. Everything we used in the problem from up above, the -2 and the -6, should still be there. Okay? All right, let's go to the next one, number 4, and we'll check our answers here in a few minutes. Find the equation of the parabola with the x-intercepts. So they're giving me that the x-intercept is equal to 2, and they're giving me an x-intercept of -5. So what they're doing is they're giving me 2 of the x factors, which means if I set this up, we have y equals a times, this will be x minus 2. Excuse me, again, we just use the opposite. And then we have x plus 5. And again, we're just using the opposite. That's using this formula that we're being given up above here, this formula. When we're given 2 zeros, we take those zeros right here and they just go into the equation, okay? We'll go ahead and use our coordinate that's given to us, the -1, -6. And so we'll put in a -6 is equal to a times, we're going to use a -1 minus 2, and then we're using -1 plus 5. Okay, that's just using the point that was given us, the x and the y, and now we're just going to solve for a. So we have -6 is equal to a times -3, and then times 4. So we have -6 is equal to 12, a and then -12. And if we divide by -12, we get a is equal to +1/2. So now rewriting this function, we're not done yet because it wants us to write it in standard form, which means we have to multiply this whole thing out. We're going to have y is equal to 1/2 x minus 2 squared, x minus 2 plus x minus 5. We're going to take that x minus 2 and x plus 5, and we're going to go ahead and multiply that out. Okay, so we're going to end up with an x squared plus 3x minus 10. Again, that's from the fact that if I took -2 and 5 and add them together, we get this 3. And if we multiply them together, the -2 times +5, we get the -10 that's right here. Okay? So now let's just distribute this out. We have y is equal to 1/2 x squared plus 3x 3 over 2 x, and then minus 5. That's just taking the -1/2, the +1/2 that's there and distributing it out to the equation, okay? So now let's take a moment and go ahead and check our work here just to make sure that everything looks good. We have y is equal to 10 divided by 9. Then we had x minus 2 squared, and then minus 6. And what we're looking for is the vertex is at -2, -6, which matches what we said in that problem. And we have a point at -1, 4. If I go to -1, we have a point right here at -1. Actually, let me just go ahead and write it, -1, 4. Okay, and you see that that point is actually right there on my graph. Okay? All right, let's go to the second one there that we just did. We have a coordinate at 2, 0, 2, 0. and then we have, and I'm going to label that, then we have another coordinate at -5, comma 0. I'm going to label that so we can see it. And then we have a point given to us, which is at -1, comma -6. Okay, we'll label that. And we can see all the points are given to us here. And our job was to try to create an equation that has all these points. So if we go ahead and plug in the equation that we came up with, which is 1 divided by 2, and then x squared plus 3x, and then minus 5. I'm sorry, it was 3 over 2. So it's 3 divided by 2, x minus 5. You can see that that graph now goes through all 3 points that we mentioned here. Okay? All right, let's continue on. So now we're just doing a couple of graphs with all this information. We're going to just pull information straight from the equations. When we look at this, we know that the A is positive. The A is negative. Okay, that's right there. Okay, we know because the A is negative, the graph is going to open up. We know that it is a minimum because what's going to happen is the graph, not a minimum, the graph is going to be a maximum because the graph is no longer going to be like this, it's going to be flipped over. Okay, that maximum value we're going to take straight from the vertex. So our vertex here is -3 and +8. X is equal to -3 is the axis of symmetry. Okay, and that comes straight from here. The maximum value is 8. That comes straight from here. Okay, the x and the y-intercepts, we're going to have to solve those. So the x-intercept, we're going to set y equal to 0. So that means we have 0 is equal to -2, x plus 3 squared plus 8. We'll solve. We have -8, -2, x plus 3 squared. Again, that's just moving the 8 over. Divide both sides by -2. We end up with 4 is equal to x plus 3 squared. Take the square root of both sides. We get plus or minus 2 is equal to x plus 3. So we get -3 plus or minus 2 is equal to x. So that means if I was to solve for each one of those, -3 plus 2 is -1. And -3 minus 2 is -5, 0. So those are my x-intercepts. My y-intercept, we're going to go ahead and set x equal to 0. So that means that we're going to have f of 0 is equal to -2, and then 0 plus 3 squared plus 8. So that means f of 0 is equal to -2. This will be 9 plus 8. That's going to be f of 0 is going to equal to -10. So that means my y-intercept is at 0, -10. Okay. When we're talking about the domain, remember we talk about the fact that the graph goes to the right and it goes to the left forever. So that's always going to be the same thing. It's -infinity to infinity. The range, remember we said, is going to be from the bottom to the top. Okay. Bottom to top, and we're going to have to use parentheses or brackets here. So let's see what happens when we graph this, okay? My vertex is at -3, +8. You got that point right there. We have an x-intercept at -1, 0, and -5. So -1, 0, and -5, 0. Those are my x-intercepts on this one. Okay. We have a y-intercept at 0, -10. We have an axis of symmetry at x is equal to -3. Now I want you guys to notice something here. With the axis of symmetry, remember that all the points across or away from my axis of symmetry should be the same distance. So it's 2 in this direction, it's also 2 in this direction. So you see how I've got 3 away in this direction? To get my 5th point, we go 3 in the other direction as well. And there's my 5th point right there from that. So now we can go ahead and just make our curve. And we've got everything from our graph now in here. Okay? All right, let's go to number 6. Same exact idea. We've got the A value here is positive. Because it's positive, this is going to open up. My vertex for this, we don't know yet, so we're going to have to calculate that. However, we do know that the vertex is going to be a minimum because it's at the bottom of the curve, right? To find our vertex, let's go through find first the axis of symmetry. So that means we have x is equal to -b over 2a. So that's the opposite of our b, which the opposite of my b is our opposite of b is going to be positive 12, because my b is a negative 12. We're going to take the opposite, so that's going to be a positive 12. 2 times a is 2 times 2. So we're going to have 12 divided by 4, which is 3. So my axis of symmetry is x equals 3, which just happens to be my value for my minimum or my maximum. Okay? All right, my vertex, we're going to plug that 3 back in. So we're going to have 2 times 3 squared minus 12 times 3 plus 10. So we're going to have, throw this in our calculator, we get negative 8. So my vertex is going to be at 3, gosh, sorry, my stylus is going bad right now. I don't know what's going on. 3, negative 8. All right. For my x-intercepts, we're going to set x equal to 0. Sorry, y equal to 0. We're going to have 2x squared minus 12x plus 10. I'm going to factor GCF out. I'm going to divide everything by 2. So I get x squared minus 6x plus 5. This is factorable using the x method. We're going to have x minus 5 and x minus 1. That's because minus 5 minus 1 is minus 6 when we add those together. And then negative 5 times negative 1 does equal positive 5. So that checks out as well. So we're going to have x is equal to 5, x is equal to 1. So we have 5, comma, 0, and then 1, comma, 0. That's my x-intercepts. For the y-intercept, we're going to set x equal to 0. So again, if we go here, we set x equal to 0. We're going to have a 0 here and a 0 here, which means this goes away and this goes away. So we're going to have a y-intercept at 10. Okay, so the domain, it goes left forever. It goes right forever. We didn't do the domain range for the top. I'm sorry, the range for the other one. The range for this other one, it goes up, it goes down to negative infinity, but it goes up only to 8 right here. Okay, so the range for this is going to be from negative infinity to positive 8 at the top. And it's including 8, but we don't include negative infinity because I can't count to negative infinity. Okay. For this one, we'll get to the range in 1 second. We've got a vertex at 3, negative 8. And then we've got 5 zeros, one of my zeros. And then we've got 1 0 is another 0. We've got an axis of symmetry that goes x is equal to 3. Okay. And we've got a y-intercept at 0, 10. So just remember, since it's equidistant, when we look at this, since it's 3 in this direction, it's going to be 3 in the other direction away from my axis of symmetry. So we'll have a 5th point right here. Go ahead and graph that, and there's our curve. We go up to infinity, and we go down to negative 8. Okay, and so my range for this is going to be from negative 8 all the way up to positive infinity. All right, let's move on to the ACT questions. We just have a couple more minutes here. When we look at the parts that are taking place here, there is a reflection over the x-axis is right here. The vertical stretch of 2 is right here. And then the horizontal shift 3 units to the right is not there. Down 1 is this one right here. So the answer for this is going to be letter B. Okay. For the roots, if we know that this is x is equal to 1/2, that means if I multiply it by 2, we're going to have 2x is equal to 1. Then we have 2x minus 1. Oh my gosh. 2x minus 1 is equal to 0. And if we move this over, we're going to have x plus 4 is equal to 0. So my factors for this are 2x minus 1 and x plus 4, which is D. For number 9, it says that this is basically just a quadratic. We have this equation right here, and we want to know when does it hit the ground. Means when we're looking for when is it equal to 0. When's the height equal to 0. So we have 0 is equal to negative 16 t squared plus 80 t plus 40. And for when we're doing these problems and you're allowed, this is ACT stuff, you can use your calculator. So let's go onto our calculator and see when does it in fact equal 0. We're going to have negative 16 x squared plus 80x, and then plus 40. And we want to know when does it hit. Well, we can see right here that it hits in 2 spots. It hits right here, and then hits right here. We're not looking for the one that's to the left because that's a negative time, but we want to know when does it actually end up right there. Just touch that point, we can see it's at 5.46 seconds, which happens to be letter D. And then for the last one, We use this thing called the discriminant when we're doing this. And the discriminant is b squared minus 4ac. This is the inside of the quadratic formula. And remember that when we do the inside of the quadratic formula, if we have a positive value, we get plus or minus the square root of a positive number. If I do the square root of 0, what ends up happening is it just ends up equaling nothing because the square root of 0 is just 0, right? But what happens when I have the square root of a negative? Well, when it's a square root of a negative, we end up with an imaginary answer. And so what this is saying is when we have no real solutions. So that means when is this going to be negative, or another way of saying is when is this going to be less than or equal to 0? What less than 0? So let's plug in our values that we have here and solve for this. My b value is a 4, so we're going to have 4 squared. My a value is a 1. My c is just m. And we're going to solve for m. So we have 16 minus 4m is less than 0. That means that negative 4m is less than negative 16. And if we divide both sides by negative 4, we get m is greater than 4. And there's your answer, when m is greater than 4. So that is it for the review. Again, make sure that you know how to do these problems. If you need help or extra practice, I would recommend maybe go on AI, ask it to create some, go on Delta Math, ask it to create some, go on YouTube and look up this stuff. There's just a ton of problems that you can use. And we have our Algebra 2 book, which has these problems as well. But study it. You got it. I believe in you. Take care, and we will see you later.